Well, let's wait until others join us and we'll start. Okay, we can start. Hello everyone, welcome to our today's session, and here you can see the agenda we have planned for today. First of all, we will finish with practical examples of object-oriented programming. We started on Monday, so today we will cover the topic about generics. So we'll have the examples with them, and also the explanation. I will explain what you need to do in your next home task, which will be activity 04, and we'll just explain all the details you need to do there. And after that, we will have the presentation about the inheritance. Alright, so I think we can start. First of all, let's start with generics. So basically, as you know, we have in Java we have the parameters which can be used in methods, also the attributes which can be used in the classes. So basically, many different types. Many different types can be used, and so as we know, we can use casting and all these things, but in general, how can we just unify them? Because again, we can use casting, we can use the superclass and inheritance design there, but I mean, the question is that we have that what can we do in case we don't have such option to use the casting and inheritance. Like mostly that's related to the collections, and basically the types which cannot be casted directly to object tab, and so that's first. And secondly, if we talk about object tab, it basically so as we know, object is the parent for all the classes in Java, and so I'll get it right here as you guys can see. But it means that all the types, all the classes can be cast to object. But what to do if we want to restrict such option during the compilation of the program? So it means that in general we will have the type which, let's say, will be unknown, yeah, but we can define it during our code writing. So we write the code, then we provide some code there, and then we can basically the compiler will check all the issues we may have with the code, and that's first. Yeah, so we can have such check. And secondly, we do not need to use the casting. And the third thing is that actually the type will be restricted. So again, if we work with the object type, it means that in the same time in fact we can actually pass all the objects there and pass them back using casting operator, but yeah, this takes some more coding. Actually, if you cast to object, it means that at some time you'll need to cast back from object object typed variable, and it means that you need to use the casting. You will need to use checks if something is wrong or not. So that's mainly the solution, which may not be so stable. But in fact, basically the question is what we want to do if we basically have similar logic for different types. Again, this will be the classes. Maybe the classes which are not linked. In some cases, it's also possible that classes are not linked using the inheritance. And so the question is, how can we, let's say, unify the classes, and how can we unify the classes, and also how can we work with them. So let's first of all create the logic. So first of all, what can we do? First, let's create the class, just print class, yeah. Print class, and here I want to display the element. Let's say choose public void display, and here I want to display something. So from here I will pass the parameter which I want to display. So maybe iterate new subject, but I don't want the type of the parameter which will be passed here. So to do it, I can define the type here. So this will be type, and here I can provide the type that would be, say, element, and here I can print the element from here. In this case, as you can see, I do not know the type of the element. I do not know the type of the element, so in theory I can print almost everything. But first of all, what I want to do is I will create the object. So maybe let's write comment. The element is unknown. Okay. So we don't know, but we actually print something. So let's create the object here. Print. Here we need to provide the type, and as an example, I can provide that from this class I will use the integer as the type. From this object I'll use the integer as the type. So that will be object, and I create class print. I provide the type that's integer, and after that I can display the integer that will be 25 or 35, for example. So this will work, this is correct. So I provide the integer provide integer, integer type at the beginning, and in the beginning of the definition. So the moment of definition of the object, and it means that I can use I can use the D type of the used in the object as integer only. So I can not, in this case, this for instance string. That's not acceptable. Can't do this because string is not integer. It's not integer. As a small example. So, and again, the advantage is, instead of using just the object, if I use the object instead of t, the compiler will not understand that that only integers to be used here. So here I directly provide that only integers to be used here, and nothing more. Right? So that's why we can use type here. That's one of the options. But right now let's maybe have a little bit more advanced example. So that would be say max values. Yeah. So first of all, we can define the types at the beginning, as we can see here. But in general, we can also just use the statics. It's not mandatory. It's not mandatory to use the statics to define the types. Define the generic types at the beginning. We can also use static. We can use them in we can also use them in static methods. So what does it mean? It means that like it will not work like in this case. What we've done here, we provided the type at the beginning. At the definition, at the creation of the object. And so we provided it here, and then the compiler checks it for all the methods located here. So it means that the object with the type t is created. Then it is, let's say, fixed. So we created, we provide integer type, then it's fixed, and in all the places where this t type is used, that should be integer. Comparing to the static methods, this will work differently. For the for the statics, we do not create the object. That's why there's no such option to just create it at the beginning. So it means that the check and the compilation will be done for the methods separately. So, and in this case, we can define it, say this way. So we have the type. Here will be the type, and let's say get maximum from two elements. So these will be the A and the B. Static gap, yeah, of course. And here we need to. So here I'll have max value. And I will return max. Right. So what's the issue here? Sorry, yeah, that's correct. Wait, sorry, yeah, missed another element. Okay. And here we need to initialize it as usually. So maybe just to get rid of the error, I will initialize it as A. So, and this is the definition of when we use the statics. So as we know, again, as I said, for non-static methods, we can use the definition of the class. And again, here we have type, and then after that, so we use the comparison symbols here, and then we just we put it in comparison symbols here, and then we just use it inside the class. For the statics, again, we don't have such options, and it means that the type needs to be defined when we call the method. So here, what we see the type again defined in the same way as here. So that would be just the type which is used in the definition. So let's say, so public static, that's how it makes sense for you, as we usually use it, and then the type, the generic type which is used, which will be used in the method. Will be used in the method, and then we have T, which is returning type. So this part is the same as for all the methods, and basically this part is also the same as for all the methods. We just have this definition of T type in the middle, in between these parts. So here we have just the definition of the type, and after that we just use it as all the types we want. So that's one thing, and basically we should not be able to use simple comparison operator if we want to just get the maximum. So here's the first problem we face. Actually, we can let's say, yeah, we can do nothing. We don't have any options to do some checks, some basic actions with this T type, because again that's just empty type without any definitions. So basically, say we have nothing to do with it. It's the same as if you define the type as object. So with object type you can, okay, and for object you can call some methods. The same should be called for T type. It means that, yeah, all the methods you can call from object you can call from T type as well. So basically, again, another point is, if you don't, if you just define the method this way, define the, let's say not the method, but define the attribute, the type, generic type, define generic type this way. This way it means that you can only do the same actions as you can do with the variables defined as object. Basically, in this case, you can use the same way as we use it for object class. But again, this is not what we want to have. We want to do something more meaningful. So, for example, again, here we want to get maximum. And yeah, first of all, yeah, then before we start doing something, please remember that for generics, we have these template types, so we can use the types, and all the types must be reference types. So we cannot use primitive types instead of t here. Yeah. So please remember this point, because it's so important. Please remember that we can only use reference types in generics. So it means that we cannot use any primitive. Cannot use any primitive type here, only the generics. And it means that so it means that type T will always extend class object, as all the reference types do. And that's why, again, right here you can see some methods here. So these are just all the methods which belong to the class object. Yeah, that's about it. Yeah, and since here we want to get maximum, it means that we want to compare these two elements, and we have such option. We have such interface or such class, which is called comparable. So basically, to compare something, we need to. Oh no! So I think if I send 1 moment. Yeah, one more thing which I don't like the definition of the generics is that for generics extends works, let's say works for extends and for implements both in terms of object-oriented programming, in terms of it. So in this case it means that we use extends and for the classes and for interfaces both. So if we want to provide the type we want to extend, or we want to extend or implement, then we always need to use the keyword extends. So that's maybe one tricky point. And so here we want to get maximum. Right. So I will define the element here, and here I can check if a compare to. Please remember if it returns value which is greater than 0, then we return. Not need to prepare the variable here. Because I can just simply return it from here. Else, if a compared to b is less than 0, it means that b is greater than a. So that should be b. So please remember if I compare the returns negative value, it means that A is greater positive value, so taking the positive value means that A is greater than B. So same as from here, and else the last case is that so it means that A compared to B equals 0, which means that basically we can return one of them. Yeah. So that's going to be this case, and yeah. So now we have the method, and we can call this. So that will be max values, again, no types here. So here we check. Here we call the method, and here I need to provide the values, so those will be this one, and okay, this works in this case, and that should normally work as well. Let's check. Oh, sorry, not printed it. The method system out print line will work for any type. Please note that this will work for any type. It will work for any t-type. Please remember that each object in Java can be described, let's say converted. Yeah, let's say converted to string. And now note that we have the method to string in object class. So that's why in this case that will work for any type. We don't need to care about the method system of line. And yeah, here we have the value 36, which is greater than the 1. This same way this will work for strings. Max values. That's maximum. That will be the string A, B, and something like BVA. So in this case, that should return us, I think B. BVA. Yeah, because B is greater than A. Yeah, that's why this will return us. This will return us B value, right? Yes. Let me check for more such examples. Yeah, what can we also do is just implement, let's say, another class. So here again, imagine we have just a box of items. How I only find box? Okay, I will find this one. Box of items. So this will be the box of items, just the box where we can place any items we want to place. So that will be inside this method we'll have the list. Oh, again, that will be the type. And the type will be again. So this is a class which represents the box of items. with one specific type, which will be defined as true. So, and here we have we will have the collection. It will be the list, which row. So again, here we can use the same type. Okay, we can use the list items, and here I will provide type T. Let's define as the class. I think I can skip it. That should normally work out. If we want, we can also do it this way. Okay, for some reason it's... Yeah, okay, that was just automatically suggested. Okay, we normally should use this one, this approach. Alright, and here we can, what we can do here, we can do some, create some methods. So, first method will be, we'll add item, copy void, add item, write the type item, and we'll add it to collection. So, that's what we can do. Remove item, delete items, and I can remove the corresponding item. Yeah, maybe I can also show items. Show items. And right here I can use the iterator and go through all the elements of the collection. So this will work. Yeah, this will be the way same as we do for all the iterators. While iterator has next, you can just simply print out the element. Maybe we can print them as I think that should be fine if we print them using the line, using the way that each element will replace that and separate line. So that will be iterator next. Right, so yeah. And then here we can use this approach. I will comment out the object before, and yeah, here we can create the object which will be the box of items, for example. So that will be box of items, and I would say that the box will store. Yeah, maybe let's create the class toys. Toy. And yeah, so basically without logic, yeah, we can implement the logic here. I'm not doing, but just in case. Or yeah, so implement the logic here if you want. That's not so important for us. You can just do anything you want here. Just a class toy. Anyhow, so here I'll define the toys. So that will be a box of toys. And here I define a box of items. I provide the type. And the type will be and here I can add some toys. For example, yeah, just let's do it this way. Let's say beer. So not beer. So yeah, maybe let's create beer, which will be the toy as well. So for example, it extends class toy. So yeah, implement the logic here. What else we can add? Okay, let's create zebra, for example. Also implement the logic here. So, and here we can add any tool we want. So it extends. Toy, in this case, compiler will understand that this object will use toys in the toy something, so we cannot place like cars or the computers inside this box. So what will we have here? Let's create some toys, so that will be here, and here. And I can add it to the collection. So this will work. So if yeah, here I can also put it inside. And I can also inside here. So in this case that will work. If I create just a separate class, let's say that will be computer. Okay, that's more. It's not auto-occupied. So if I create computer, then I cannot add the computer here. Can't. And the computer to a box of toys. Yeah, that's obviously because computer is not a toy. Yeah, if you implement logic here, it's not so important for us in this case. On the opposite, we can create say the box of say electronics class. Yeah, we can use electronics. Also just any logic here, and I can extend class electronics. Also a box of some tech items. So that will be a box of text, let's say, and you can create the box of items, and here I pass the type, which will be box, right, so even a box of items, but electronics again. So box of items. Box of items, this one. Wait, not again. Electronics, of course. Electronics, and right here I can add that computer. Wait, sorry. So what's the issue? Oh yeah, of course, I forgot to create computer. Alright, so basically here you can see, here we have the magic, let's say, when we talk about generics. So in fact we have one class. The class is box of items, but in fact using this class I can create different objects with different templates, and and it means that I can use a different So here is the, let's say, trick key point of the generics. The same class, also the methods, classes, same methods can work differently. For different let's say definitions for different objects. And yeah, this is what we want to achieve. Yeah, so this is about the simple definition. I will also show you one additional thing what we can use here. One moment, I will quickly search for the example. Yes, about extending. Yeah, one more thing to show about the extension. These are also called bounds. And here you can see that we have the example where we have only one interface provided here. Like, it means that type of T must extend. In this case, it must implement the interface T. Yeah, I think I have not mentioned it, so I'll mention here. This means that the type T must implement the interface comparable. Okay, do I have, okay, it's something, have some bugs. Okay, guys, thank you very much for letting me know. One moment, and maybe I'll switch to the different internet source. I should be back now. Yeah, I should be back now, and please let me know how is it now. I think that this approach with this internet source, that should be better. Please let me know if you're still facing such issues, but it should be better now. Okay, so yeah, let's go back. Here, in this case, again, it means that the type T must implement the interface comparable. But also, what we need to do if we want to have some multiple restrictions here, let's say, for the types. For example, if we want to compare the numbers only, so what should we do in this case? In this case, we can do it this way. So that will be the public static. I define the same way extends. So first for that, extends comparable, and I can also provide another type which should be extended here. So that would be number. It would be number, and yeah, that works. Don't worry about the red the one we had before. And yeah, you can just get maximum number. So that would be then PA and PV. And right here I can basically copy paste the logic here. But in this case we use the restriction that this method will not work for strings. So, oh, okay. That's okay. We do not have such type. Okay, I do not have such type. Let's quickly check which type can be considered as the super type for all the. Okay, we have number. I think I need to. Sorry. Okay, that's interesting. Why the number? Why it is not visible? Let's do this way. Okay. So that was so crazy, but okay, that works. So yeah, is it really this strange way? So yeah, for some reasons, yeah, I have not noticed it before, but yeah, the number should be defined on the first position. That's strange, but that's fact. Okay, that's really interesting. Haven't noticed it before. Okay. Yeah, if we want to compare the integers only, so we can use max values, and here I can get the max number. So again, this will work for integers, for numbers. Okay, works for numbers. The same should be with doubles as well, I guess so. Yeah. Okay, for doubles. It's okay for doubles as well, but not okay for strings. So, just copy paste this part, and so I cannot use this for strings. Cannot be used for strings because can't be used for strings because string is not a subclass of number, right? So in this case we have the restriction which does not allow us to use other type but number. In this case, in this case that will not work. This will not work as well because okay, maybe here I will explain. In this case, after the break, not okay, because the types must be different, must be the same. Must be the same. But I will show you after the break what can we do in this case. And yeah, please let me know if you face the issues with loggings. Just because I think that should be better now. In case you still have, please let me know if it's better or not now. Okay, let's have a break. Okay, let's continue. I really hope that should be better now. Regarding the logging, again, if I'm still lagging, please let me know, because that's maybe related to the connection to the internet, but I already changed the source, so I switched to my mobile hotspot. I really hope that this should help. Otherwise, there may be something wrong with the connection in the place I'm currently in, but that's the same place I previously been. And let me quickly check the internet speed. I have it seems that the speed is quite okay. So that's maybe on the speed. The memory is also fine. Seems so. Seems, yeah, half of memory used. CPU is not overloaded. Okay, please let me know if still something is wrong. Okay, let's then continue. So yeah, as I promised, as we can see here, here we have one not small thing, but one really important thing that here, right here, this is in the same case. Please note that A and B should have the same type. Or it's also possible that we have this case, we can try do it this way, but yeah, that should not work. That should not work. This can work in case yeah, let me quickly, here we have maximum, okay, and then we have not sure the example because I cannot imagine the example, but so basically how does it work? It should first we check, I mean you provide both types, and okay, no, maybe let me maybe quickly create two additional classes just to understand it correctly. So we have class A, which is without some logic, and then we have class B, which extends class A. So, and in this case I also want to create so let's create this class C, and here I'll create a public static method void so just for test, and here we will add two elements. Oh, sorry, that would be just generic type D. So actually here the sequence must be that the template type is before void and before the returning type. So here I can provide two elements, D okay. And here I want to pass the arguments, these two types. So first of all I create just one object, that will be a object. Create it as A object, I'll create B as B object. So that will be B. And after that I will try to pass these objects to class C. So, and let's quickly try to pass them to this object, and yeah, as we can see, and what I wanted to say is that that in this case the types will work. If you do it in opposite direction, okay, that should also work. You cannot provide say a moment. Oh, okay, so here the type that's interesting. Let me think. That's interesting. The compiler does not check these two elements. Oh, okay, because in theory they both can be the type of. That's interesting. Let me think why. That should not normally work. That both types are acceptable. No. Okay, maybe let's. Okay, because it considers both type as the objects. Okay. Okay. In this case, yeah, because if I do it this way, that's yeah, but that still works. Okay, here we have the number and the number. Okay. That's interesting. Yeah, and yeah. In addition, when you type something, you can type here. But yeah, so I think yeah, in this case that should work for every type. That should work for every type. So basically here it will work for any type. For any type. Because it will consider the type as object. So in this case, that should not normally work. Again, if you have some different types here, I would say something like this. Then it just recognizes the type as object. So when you navigate when you navigate the cursor to the method, then you can see that it considers the type as object. But in addition, yeah, maybe I will call this type any. Test any, and I will name it here. But what I can do is I can test current super, and in this case that will be, it will extend the class A, right? So, and in this case we can check test current super, so that would be A, so not A but A object, and this would be the object, and in this case that works as well, because both classes implement the class A. Yeah. So that's fine as well in this case. In case you want just to have you have some more restrictions, like you can also define multiple types here. So in this case I just use T, in addition you can define some more types and so on. So you can define as many more generics inside. Right, so that's about bounders, about bounds, and the last thing. One moment. Yeah, we will have the last case here. It's so-called using wildcards. So in most cases, the generics are used for the collections. Generics are used for the collections, and in this case, we may see some interesting things. So first of all, for example, again, I just have the method where I can pass the collection. So that would be the method where I can pass the what? Yeah. Where I want to pass. So basically, I will not use the generic the template type here. This will work a little bit differently. So here I'll have this method for class, let's say class A. And right here, for example, I can pass the collection, the list, let it be the list of A's. And here I just pass the list. And here I can write the logic here. So here I can write an logic and just write the logic here. What's the problem with this list? So as you can see, I can pass the list of A's. Yeah. So it means that the list should implement the elements with the class A. But what's the problem? As we can see, B also implements the class A. So in theory, we can also have such cases that when we want to use the list of B's and just simply provide them here, because they both will have the same the same options we can use, and that's why the question is why can't we just use list B instead of list A, because B extends A. But what's the problem here is? The problem here is so what can we see? So yeah. So here I can call the method for class, and yeah, first of all I can create the list, and then create the list of these. So that will be list these, and I create the list. Yeah, so instead of A, B, C, that can be any type. You can imagine that's not so important for us. And so I provide the list here. And what's the problem? The problem is that we cannot not do it this way. Because we can only provide the list A to the method, which is defined here below. Right here you can see that we can provide a list of A's, despite the fact that here we used B, which is the subclass of A. So it means that for the it means that the rules of the inheritance do not simply work for generics, but for the collection, for the usage of the collections. So in a simple way, that would be if you just, for example, if you have the list of numbers, so maybe that would be more makes sense case. Okay, maybe let's create one meaningful example so that can be more understandable for you. So have max values. Okay, so for this method we have get max value. We can create the same method for the numbers, right? So we have that public static. So that would be the collection. So that would be the let's say. So we return the number, and that will be get max value from list. And here we provide the list of numbers. The list of numbers, and here I provide the numbers. So here I will define the value, which is, maybe here I just return the collections. Here I can just here I can just pass the maximum value here, and we can already see what we will do next. But yeah. Okay. Moment. Okay, we can implement the method by ourselves. That's not so important. So that would be number. Just max value, and so that would be number. And okay, maybe let's imagine that we have only positive integers, only positive numbers, but maybe let's run this one. Oh no, sorry, I'll just do this one. I'll just get so then I can get the iterator and just go through all the numbers and can find the last, the biggest one. Yeah. So that would be one of those bounties usually. What's next? So if to find the current number, okay, next, then it means that if the current number is no, we can do it a little bit differently. Oh, no. Okay. yeah, right here we can see the problem. The problem is that we have the number, but we cannot call the method compare. That's the first issue. So it means that we need to get the option to call both numbers, or to use both superclasses at the interface. So number and the comparable for the list. And yeah, the first problem I already shown to you is that we can provide the list with the type provided here, which is not so flexible for us. So yeah, in this case, for the lists for the collections, we want to again use the template type, and this would be type T, which extends number and comparable. Comparable. And so here we oh yeah, of course, to compare with T. Yeah, so in this case, yeah, in this case I need to also provide the returning type, so the returning type will be T as well. Right? Okay, in this case that works. In this case that works, but this is not what we actually want. Okay, in this case that's worked fine, but let me think. We'll proceed differently. And we can use this way as usually, but okay, I think this should not work. Yeah, because here we don't have, but okay, yeah, that's maybe not so important for us. Basically the idea is here is that maybe for numbers will not implement here the logic, but what I wanted to say is that for this particular method we can pass the list of numbers only. So we cannot provide the list of, let's say, integers, despite the fact that integers are also the numbers. So if we find the list as, find the parameter numbers as this number, we want to be able to provide the list of integers. Yeah. And in this case, how can we get rid of this issue is that we do it this way. And I think here we can also do it. So that would be, yeah. So in this case we can provide any collection with the type which extends number type. And yeah, this can be applied for all the classes, for all the subclasses of the classes. Right? So this is basically the way how we can escape this issue. And also inside the code we can use the question mark. It actually means that, so if we use the question mark, it actually means. That the type is one of those which extend in this case number. We can also do it this way, that here we provide the comparable. The comparable will not work in this case. Only one type. This will not work. Same way as for the this will not work the same way as it worked for as it works for the just one type. You cannot use multiple types here. But okay, that's about the generics and how can we use them. If you have any questions, please ask. And you'll have one task related to generics, and don't remember which activity that was extra activity, but I don't remember which one was it. Let me quickly check. I think that was the 6th activity, so that will be the next optional activity to you. This was a part of presentation of advanced features. There was no presentation about it, but you can do it as the next extra activity. I will explain you what and when should you do with this one. A little bit later I will have a presentation about some other these features, but about the generics, let's say. I'll explain. So first of all, let me explain about the home task. The next home task you will have is the activity of form. So that's about object-oriented programming, and when you take a look on what is asked in Adobe, is that you need to implement all these classes. So here we have the road class, transport class, and transport management system. Traffic management system. So first of all, what you have here. Here you have again what you need to do, and maybe let's quickly go through these requirements. First of all, again, you need to generate a constructor using the fields. So to generate the constructors, you can go to source, and here you can generate constructor using fields. So this will just simply generate this type of constructor route, and then you can provide the parameters here. So you can generate it from here as well using generator, or we also call it wizard. Sometimes we call generators as wizards. That's the term we use. So that's the first thing. Then you need to create a constructor without the parameters and initialize the values with the empty values, or zeros. Then getters and setters for the parameters, then you need to create the method toString, and then using toString method you will need to show the show details about the object. So here you will see some from tool. Not you'll see, but you need to show the details, like, so since this is the road, so it will be from one place to another place. There are this and this kilometers. Yeah, so that's the starting point, yeah, actual point, and actual front point, and the actual 2 point of the object of the road. And then, yeah, the value will be the length of the road, the distance. Yeah, so that's minus 3 join, but m dash. So that can be, yeah, there are 2 types of dashes, so please be careful here. So once you implement the class road, you will also need to implement the class transport. And for the transport, there will be some similar things. You will need to generate constructor using fields again, then getters and setters, and then also generate the string and create the right string. So please be careful with the strings, with what is the content of the string, because that should be the same as it is defined. Right, so then we have the method getType, which will return the string, the type of the transport. Okay, so this will return the type of the transport. So it actually, yeah, you can use the method this get class this simple name. So what will it actually mean is that there will be, so we have the class transport, which will actually be the superclass for other transports used, other transport classes used in unit tests. So it means that there will be the classes which extend the class transport, and using the method getType, you will be able to understand which transport classes you saw. As an example, that would be that you create, again, let's say 3 classes. Class would be the transport, that may be the car, bus, or bike, let's say, and each of these classes, all of these classes implement the class transport, right? Then you create, let's say, the object bus, and there will be the bus, and you cast it to type transport. And you can create it in the way that, just, let's say, you can do it this way, the transport, so that will be transport, and you create new bus, and like this way, something like this. The transport, which is the bus, and then after that you can call the method getType from the transport, and yeah, when the program uses it, you call the method getType, and it doesn't matter what type is there, it will show you the actual type what is there. So this is the method from the which will return you the method the type of the actual type of the transport. So there can be different types there. I mean, so since this is transport, you can pass any subclass, and from this class the method will return the actual type. So if this is not clear, please let me know how this thing now works, because that can be a little bit confusing at the beginning, but so, and then the last thing is move. So again, this is the string which will provide the details when you are on the road. So it means that the road is passed to this method. The road is passed to this method, and then from this method you need to from this object road you need to provide the details of the movement. So there can be not enough fuel, for example, in the tank. Then you say that you cannot move from one place to another place. Then necessary fuel in the tank is less than needed. This will be the issue for you. This will be the issue here. And yeah, so this just need to get the right string. So this is the home task mostly used for strings, but this is such helpful to know how to construct the strings and basically have the constructions from multiple places, multiple objects. And the last thing is traffic management system. This will actually yeah, so from here you will need to pass the values where it is needed. From here you need to basically here you need to return the corresponding types, corresponding values from here. In this case, that in some cases this will work as getters and setters. In some cases, but here it's just here there makes sense things. So create the array, set transport into transports, array cell, past index, get route, set route, and so on. Alright, so this is about the home task. I think you'll have some questions about it, so once you start doing it and you struggle with something, so please let me know. And let me check what's the deadline for this one. So you have extra additional exercise until 19th of March. So let's say that this would be on the 15th. That would be the 24th of March. So 24th of March, and this would be GTM, the activity of 04. So moments. Better now. Okay, in case, and in addition, so as an extra, that would be generics from activity 06, extra 06. Generics from GTM extra 06. Okay. I've placed it in chat so you can see them. Alright, so it's the home task. Please let me know if you have any questions there. And now we can move on. So the next thing for today is inheritance. Again, the topic we already talked a lot about. So again, this will be mostly like some things which will be just for to repeat. So yeah, this way. So let's go and let's go through the inheritance again. Alright, so basically what's the idea? The idea is that the idea of inheritance is that one class extends basically based on another class or object. It means that it uses the same properties of another class and it's adjusting specific method implementation and properties. So it means that in the subclass, in the class which extends another class, we will adjust the functionality of the superclass. In most cases, yeah, there can be two different options there. The first option is, again, as I just said, it adjusts the behavior and the properties of the superclass, and another option is that it actually extends, and maybe the most usual option is that it actually extends the properties of the superclass. But yeah, mostly it should extend, because otherwise, if you just create the subclass and you just basically overwrite everything, that the question is why. Yeah, in theory you can do it, but that's mostly again, yeah, that's the important thing here. If we talk about the inheritance, so if we don't talk about abstract classes and abstract methods, then so if the class is not abstract, we extend it. In this case, that's mostly needed for to add some new functionality, because it means that in superclass you have the method, you have the implementation of this method, so there's some things there, and if you extend, so if the class is inherited, it means that these methods, they're protected, but these methods will come to the subclass as well, and in this case you have an option to override them. And in such cases we usually work with the methods in the way that we keep the previous functionality and we add something new. So, and this is the cases. These are the cases the inheritance is mostly about. So then, as I mentioned, it can be, and usually there are some services, some service classes, I would say, which do some service things, like it can be data migration or data movement, middleware, somewhere, all data services, and so on. So these classes usually extend some, let's say, general classes. Basically, how it can be done. For example, you have the framework. You can use for your, let's say, application or your program, which does some things. For example, it moves the data from the front end, that would be the website, to the back end, which is a server, which can be some kind of server. And then you have the framework, which actually there's the generic framework with the specified logic there, which has some usual basic stuff, like you have some methods which uses the entities which move in different directions there. And yeah, what you can do, you don't need to just change the logic in in this framework, but what you usually will do is that you will have your own classes, your own logic, which will actually extend the logic before, the logic defined before. And what does it mean? It means that all the previous logic will stay the same in one place. I mean, everything will be the same as before. In addition, you can, so it means that you create your own extension. You actually create a subclass which will extend the previously defined superclass, and after that, basically you will have all the same functionality. Plus, in addition, you may add something new from your side. Yeah, this is one case. And again, another approach, which is maybe not usually if you have another thing that you have the superclass and then you just create a subclass and basically override everything with the new logic, like nothing nothing is left from what is written in superclass. Yeah, so you know, let's say you have 10 public and protected methods and in the superclass, and then you create a subclass and override them all without calling the superclass. You just create your own logic for all these methods. This case is also fine, but in this case, again, as you may understand, that the usage is quite different. So it's not like you use something what was created before. I mean, that's also fine case, and usually there are the cases which like half of this approach and half of another approach. But yeah, in such cases, if you have such cases, then please, if you create your own framework and your framework just works in the way that everything should be overridden, then maybe in this case, please think about the approach of using abstract classes or interfaces, because again, the second approach is mostly used for the abstract classes. We'll talk about abstract classes, but just you already know what the abstract classes are. But again, just before we continue, the abstract classes usually are about the case where you just create logic on your own. So you have the, let's say, the base class. The base class has the methods, has some methods which are not implemented, and it just gives you the opportunity to write your own logic in the subclasses. That's why we have abstract class, but again, let's maybe a little bit later about it. So again, for example, when we just use the inheritance and why the inheritance may be needed, like you have the employee. This is the class. It can also be the abstract class as well. In this case, that's not so important. But yeah, you have the employee, and then you have the manager. Of course, they both have some same parameters. Like both of them will have name, both of them will have salary, birth date, and yeah, maybe some details as well if needed. Yeah, so manager, you can also define the department of where the manager works. So what does it mean? It means that in addition, here we have 4 parameters which are used for the manager. So the question is, why do we actually need to define all these 4 things twice if we can just define them once? Because we know that all the managers are the employees as well. So in this case, the normal approach would be, if we use inheritance, is that we use extends, and we actually extend the employee class. So in this case, we have firstly less logic, secondly we have more flexible, more understandable logic, let's say. And it makes sense, and then we can also, but yeah, what's the difference here? Here we have the difference is that again we do not repeat the logic, But what will we have here? In this case, the class, the object which is defined as the manager, cannot be considered as employee, because these are two different classes, despite the fact that they have common parameters. In this case, manager will not be considered as employee. In some cases, it is needed. In some cases, there must be such thing that the manager is not considered as employee, because there may be some things like you can add some additional parameters to employee which cannot be applied to the manager class, and in this case we cannot consider the manager as employee, but this would be the bad design, I would say, because normally from normal life we always consider the manager as employee. So in case of bad design, of course, we cannot use the inheritance. But in this case, we imagine that design is fine, and we can use the inheritance. So here we can have some more terms jargon. Because in programming we usually use different terms which describe actually the same things. And for inheritance we use so if the class is inherited, we call it is the class where we inherit from. Which is inherited. We call this class like extended class, parent class. About the base class, this is maybe not so correct term to use, because I would say that the base class is usually used as the core class. So like imagine if we have the open the top-down design we had before. So we had the top-down design, and we usually consider we have the core class. Obviously, we have such top-down design, and usually the core class, the top class, is called as the base class. So maybe for the base class, we mostly use we mostly apply the term base for the root class. General, that's also kind of the base, but the superclass, that's the term we always use. We always use superclass, we always use parent, and the extended class does not say us a lot of things that using this term we can understand that this class has the subclasses. And then the class which inherits is called extending, that's called the child class, derived class, rarely used, but also can be called the derived class. Special, that's quite an interesting term, but also here it can be used. Say more specific, in some cases we can call it. And we usually call it the subclass. So the terms that most we use are the superclass and the subclass. So we have two ways to go. If we go up in the hierarchy of top design to this top-down design, then if we go from more specific to more general, we call this hierarchy as this going up as generalization. If we go from top down, we call it specialization. And here this is UML diagram. Maybe we'll talk a little bit about UML diagrams a little bit later, but here you may know that we use such let's say not interesting, not interesting, but such schemas, such diagrams. These are called UML diagrams. you will see them quite usually later, but and I think you've already seen them before. But yeah, these are UML diagrams which help us to describe the hierarchy of the classes. And yeah, so this is how the inheritance tree looks like. We have the let's say we can call it the parent class, the base class, the root class. For the classes engineer, manager, secretary, and then we have the director class, which is the subclass of the manager. And in this case, so in such case, we can also say that director is manager. We can also say that director is employee. We can also say that manager is employee, that the engineer is employee, and secretary is employee. But we cannot say that secretary is manager, engineer is manager, and the opposite way. Also, we cannot say that employee is manager. We cannot say that. We also cannot say that employee is director. Yeah, because in some cases, yeah, that's fact, and that's why we use them. Again, please remember, in such cases we use the casting. We use the casting because casting works in some cases, but not in 100% cases. Because not all. Some employees are the managers. Also, some employees are the directors. So in this case, the cast will work. But if the employee is not director, then the cast from employee to director will not work. And yeah, in Java we have such thing that we can extend only one class. We cannot have multiple we cannot extend multiple classes. Yeah, that's why inheritance structure is always true. So that won't be. We'll have this design later, but in this case we cannot do it this way. The director is the manager and the engineer as well. This will not, in theory, in real life that can be possible, but in real life, but not using Java classes. It can be done using interfaces, but that's a little bit different topic. So yeah, please remember that we can use access modifiers to restrict the access from restrict the access to the methods and the variables of the class. So we can use the public protected private and no modifier, which can be considered as default modifier. And yeah, so we have method overriding, but maybe let's do it after the break. So after the break we will continue. Okay, let's continue. So yeah, first of all, we have the method overriding. When we talk about inheritance, so what does it mean? It actually means that in the subclasses we can create a new implementation for the methods inherited from the superclasses. So please remember that only the public and protected methods are inherited. Not inherited, all the methods are actually inherited, but you can access only the public and protected methods when the class is inherited. And yeah, so you can override these methods. Basically it means that you can create different behavior. As I previously said, you can basically recreate everything there. I mean, you can totally change the behavior of the method, but the most usual approach is that you actually extend the behavior of the method. So what does it mean? You can use the super keyword. This will actually call the implementation from the superclass. So the implementation is executed, and after that you can add some more logic. You add some more logic in the overrided method. Yeah. So it basically means that when you define the method with the same signature as you have in the superclass, you can also change the access modifier from protected to public. That's also is allowed, and in this case, that's called. It's called if you define the method with the same signature. It means that you actually override the method. And so in addition to overriding, we also have such thing called overriding. So overloading. So please do not mix these two things, because method overloading means that we actually create the method with the same name but with different parameters. Actually we have the method and we have the parameters. We have let's say two methods, two method definitions, but they have different parameters defined. Comparing to overriding, which is just a different implementation of what we have in the superclass. This is called overriding. So it actually means that the method name should be parameters, and then name should be unique. Method declaration lines are often called method signature, and overloaded methods have different signatures. So and here we have the example. This is about overriding, where we just have the method which comes from the superclass or also the interface. Right, and then we can go to the keyword super. So as you know, when we use the keyword this, it actually refers to the current object. In JavaScript there is also such a thing usually used called that, but that's a little different question. In Java or JavaScript we have the keyword super, but this the meaning of super is not just like if you have this means that you have this object, and super means that you have the object of the superclass. Please remember that you don't actually have the you don't have different let's say different object, but something something different when we have the superclass. When you actually inherit, when you create a subclass, as I said before in this course, actually it means that you also created the instance of the superclass, in theory. Yeah? So it actually means that when you create the subclass, you create. When you create the instance of the subclass, it actually means that you also, in the same time, you also create the instance of the superclass. And using the keyword super, you actually can access the implementation of the superclass. So it means that if you override the methods in the subclass, then you can use the super to access the actual implementation of the methods in the superclass. Right, so this is what you can see here. And super is really helpful. It's really helpful, as I said, for the usage of the subclasses as the classes which actually extend the functionality of the superclasses. Yeah, this is what we have. And yeah, here we use the method super usually. Again, when you see how the super is used and when you want to use it, usually we use the method super at the beginning. So as I said, you override the method, then and the first statement is that you call the implementation of the superclass, and then you have some additional things you have in your method which you override. Right? Yeah. So in this case, since you have the class employee, you have the method get details, you have some logic which returns the string. And in this case, you will call the method get details from the superclass, so it means that this string will be returned, and in addition add some more parameters. Right, so this is the similar example we had in our previous course when we worked with toString method. It's quite quite useful in this case. Alright, so we finished with the super keyword, and now let's go to the polymorphism. Yeah, this is the provision of a single facade of two items, different subtypes. Yeah, when variable points to object, its type just declares which member it has, and so the actual object structure and methods could be different. Only members defined in reference will be available, and if actual method is overridden in a particular object, overridden implementation will be executed. So basically, it means that like you have the program, you use some types there, and the type is the class, and again you have the values which come from the place you don't usually know. Actually, there may be some framework which retrieves the values from somewhere, and yeah, so then you use these objects, and so the only thing you don't know the actual type of this object. Of course, you can check it using getType method, but get class name, but yeah, just from the compiler perspective, you have just objects with one particular type, and you may access the attributes, but yeah, you can usually what you do, you access the methods from the class, and yeah, so based on the object assigned to this class, to the variable which has the particular class, you can call the methods, and since there's possibility that under the variable of any class there will be actually stored the object with the reference to the class which is the subclass, of this type, then in this case the implementation of the subclass will be executed. So that's, for example, you have the variable defined as the class, so let's say bus, or sorry, transport. Have the method transport, then you have the method, then you have let's say the method move, and despite the fact that in class transport there may be some implementation already there, just move in some way, but in fact what will happen when you assign the bus to transport, then you can call the method move. So when you just directly see the implementation of move method defined in the class transport, but in fact during the execution of the program, the implementation of the class bus will be executed. Right? So this is what it is about. And when the variable points to the object, it's just type. In fact that's the type, but the type may be different. But it's actually the reference may be there. So for example, if there is a superclass employee and the subclass manager, you can create a reference of employee type to the object which actual type is manager. So we can pass the reference to the variable employee. And in case the manager, so in this case, as I just said, the manager has all the parameters of employee. So again, as I said, when you create the object with the type manager, actually the instance of the employee is created as well. So in this case, you can simply pass the manager to employee. This will always be correct. That's what you can see here. Set all the managers are employees, so we can pass the manager to employee. That's okay. And call the method. Then details. But what's the problem is that you cannot access. So if you do it this way, you cannot access the methods and the attributes defined specifically for the managers. Again, because we use the variable employee. If you want to access some additional methods or parameters from the class manager, then what you need to do is that you need to create or use the variable manager with the type manager, and then you will need to cast from employee to manager and access the attribute and call the method. It's defined specifically for manager class. Or again, you can just skip using creating the variable, but just do the casting and call the method. But anyway, you need to do the casting. That's the point. Right, and as it says here, you can also have so-called polymorph arguments. Because you just said manager is also employee. You can pass manager object in place of employee as the method parameter. So the method parameters work absolutely the same way as all the variables work. That's quite directly. So when you just work with the parameters, so it means that you work with them in the same way as you work with all the variables and all the class object attributes defined in Java. So you can pass manager in place of employee and use it. So like in this case, if we define text rate, have the object employee, you can pass the manager instead. That should be fine. And what I mentioned before is so-called virtual methods. This is basically what I told before when we talk about polymorphism, is that for the methods we may have so-called virtual implementation. It basically means that in class employee, for example, employee may also be the absolute class in this, and and getDetails may be defined as the abstract method. In this case, it actually means that once the method getDetails, the implementation of the method getDetails will be called from the class manager. So what basically what does it mean? It means that always, anytime you call the method from just any method you call from the variable, you actually do not call the method from the variable. You call the method from the object which is stored under this variable. So it's a really important thing to understand, because sometimes again what you may need to do, you can see in debugger or somewhere in the results that there is implementation in one class executed, but when you go to the code, you navigate in the method, you open the method, and you see that there is the implementation. There's the implementation which comes from different class. And this is what usually happens when you have these virtual methods. So please do not be scared if you see something like this as I just described before. That's absolutely fine case if the implementation you see is not the same as the implementation executed. That's because, again, the reference has the different type, not the same as you have here, like in this case. Have the variable employee, but actually the type is manager, so it means that all the implementation you call from these methods will come from manager class. Alright, yeah, let's check on the compilation time. So yeah, requirements for overriding, that the method signature should be the same. So yeah, the returning type, the parameters should be the same, but the one thing, as I already mentioned, that you can for the protected methods, you can redefine them as public. So it means that if you have some methods which are protected, then in the subclass you can change the access definition to public from protected. Previously we seen it with the cloning example. For method clone is the method which is originally defined as protected, but we can redefine it as public. That can be used again when let's say when there are the classes with the methods. So we define them as protected, which let's say are not abstract. So it means that the implementation. So basically, these are not abstract classes and not abstract methods, and so it means that they have some logic inside. But these are the methods which are not ready to be used at this point of hierarchy. So again, if we go from top to down, then at some point when we have the definition of the method, it is defined as protected because it's not ready to use in this particular class. If we go down and implement, just add some additions to this method in subclasses, then at some point it may be ready to be used, and we can redefine it from protected to public. But we cannot do it opposite way. Why? Because again, imagine if you have the method defined as public, then you have the subclass which inherits, which extends this class, so the method is inherited, and if you redefine this method, so originally the method is public, but you want to redefine it to protected, this will not work, because in this case the sense is broken and the hierarchy is broken as well, because so you can use the class, you can use the class, and then So it means that the method is defined as protected, but when you do the casting to the parent class, so it means that you have the protected method, but if you cast it to the parent class, this method will actually become public, so you can call it, and it doesn't really make sense to create it protected in this case, because you will still be able to access it by casting to the superclass. So it doesn't really make sense. Yeah? If you create it protected, but you actually can access it by casting. That's not what protected methods are about. Yeah. And in this case, it is not possible, but it's always possible to come from protected to public. Yeah. Then we also have the method, not the method, but the operator instance of. This actually helps us to, usually it helps us to understand if the casting can be done. Like if you want to cast from the variable, which is, let's say, more general than the type we want to cast to, then in this case the cast will not always happen. So that's not so safe to cast, because we may get cast exception in case the actual type of the reference is more specific, is more general than the type we want to cast it to. Yeah. In this case, to be safe, we can use the method instance of, which actually shows us if the current object is the type of, or it extends the class defined on the right. So using this one, we can check if the reference stored under the variable e is instance of class manager. And then again, in this case, we can also use, let's say, something like cases. Yeah, we can check one case or another case, or just a case else. Also, what we can do is get class methods. So for each class, for each class, yeah, so it's easy, that's also class. For each class we can get the class of the let's see, yeah, so we can get the class of the object and determine it, but yeah, usually that's called as design spell, because it's actually anti-polymorphism, because usually and normally we do the casting in the way that we cast a more specific type to more general type, and that's basically the normal case how we use. But again, sometimes that's yeah. First of all, what's the problem here if we use instance of so often? That's again, that goes to the opposite way, basically, because again, the sense and the idea of polymorphism is that we want to generalize something. So it means that we want to have the general logic, let's say, of employees. Basically, the employees, that's the class which combines all the employees and the logic for all the employees. So it means that if we somewhere use the employees, so this is the place where where we do this logic for all the employees, for all the managers, for the engineers, for the employees. It's like you have the company event where all the managers and all the employees come to, and in this case, so we have company event. So have the party for everyone. Usually it's like the team building, so you want to build your team. And in this case, in such events, it's not so fine to do, like to separate them. So usually we have the company event, so when everyone come together and discuss something, so just like a friendly build with team building. You do not just separate them in different classes. So in this case, you use employee, but you want to just separate the logic in different flows, which again means that you go in opposite way. That's why we call it in some case anti-polymorph. But yeah, sometimes instance of is really useful, but normally there should not be such issue when you do not, when you can't skip using the instance of. And yeah, here we go to the casting, and for the casting we have two options. The first one is upcasting. It means that we go from more specific to more general. That's the easiest way of casting. Again, it means that, for example, we go from manager to employee. That's called upcasting. More specific to more general. And yeah, the case which is, let's say, more anti-polymorphism is downcasting. When we want to cast the reference of the variable which is more specific or which is more general than the variable we want to cast to. So upcasting is done automatically. It always is correct. It always works. Again, because of what I just said here. Downcasting can raise some problems. Not casting exception, but one casting exception. This would be class cast exception, because it can be done incorrectly. Again, as I said, you may have a situation where you cast more general type to more specific type. Again, reference with more general type to the variable which is defined as more general. Again, the issue here may be that you in the more general, more specific type, you may have the methods and the attributes which are not present in the reference we want to use here. That's why you may have such issues. And in this cases we use instance of, and we cannot check them on runtime. Right? So here we come next to the method overloading. So what's the idea? We previously used such cases for system out print line, or just print any element. It actually means that so for such cases we can use overloading. So does it mean? It means that we built the methods for actually, let's say, all the cases. We can pass any type, and this any type, like in this case, will print us what is passed to it. If it's the integer, we can pass the integer. If that's the float, if that's the string, all the types will be all the variables will be printed out. The same way we can build your own methods. So let's say if this is calculation, you can have some different parameters for for the methods. It can be double float, so you can multiply it in some different elements, and in this case the type may be different. That's one thing, and another thing for the method overloading would be, let's say, you can define the default values. That would be like you have the, let's say you have the object. You have the object, and the object has the, and that can be the static attribute of the class, that can be the parameter defined in the constructor. So yeah, you have the method, and you may have the two signatures of the method. The one method is with the parameter, and another method is without the parameters. And in such cases, there may be such possibility that in the method you will have actually kind of the same logic, similar logic, let's say, for both methods, but one method will use the parameter provided, so the method with the parameter, so that's parameterized method, will have the logic which uses the parameter provided, but another one which has no parameters, this will use the attribute defined in the class. So that will be the default value. So using the method overloading, we can achieve the situation where we have default values. Like you may have the methods where you provide the values, but in some cases there may be some default values. And for example, in different languages, like again in PHP, in JavaScript as well, I think, as I remember, so PHP default parameter, there may be such cases. So I'll show them here. So you may have such things like default parameter. So it means that you call the method. You define the method, and for the methods you have default. You have the parameters, like in this case it will be x and y, and you may have default values here. You have default values, and it means that you can call the function. Without providing these parameters. That will also be correct. And if the parameters are not provided, then the program will use these values. In Java, we don't have such option to provide. JavaScript, yeah, that should also be possible. Yeah, in JavaScript that's also possible. Yeah, we define default parameters. One moment. Yeah, that was possible. Yeah, in Java that's also, in JavaScript that's also possible. In Java we don't have such option, but we can achieve it using methods. So like that would be, okay, maybe let's quickly implement such scenario, because that may be quite useful in real life. So maybe let's not use this example. Function. Let's take one of the examples from here. Let's quickly. Oh, okay. Not this one, sorry. Let me take some example and we can. Okay, we can maybe use the multiplication. So that would be. So that would be this way we defined it. And yeah, here we can define some more stuff functions. That will be the calculation. And let's say we multiply which is summing 3 integers. So that will be multiply 3 integers in such method, and then we'll have so normally what we do, we have parameters a, b, c, a, b, and c, for example, and then we just return a times b times c. Yeah, so just a normal case, we find called method and just multiply these elements. But again, here I don't have the option to use the default values, and in this case that would be, so if I want to use default values, what can I do? I can, instead of C, I can use, let's say, 1. Yeah, and in this case that should also be correct. So instead of C, I use 1. Unfortunately, oh yeah, and yeah, we can also just do it for one element as well. I think that we have one problem here, and so we can already see what the problem is. The problem here may be, not maybe, but the problem here is, first of all, we can see that for B and C parameters we can default them. But what's the problem is, in this case we can just simply use them as default parameters. But the problem is that we cannot provide which parameters to be used as default, because we only determine which method is called by signature. So in this case that's integer, integer, integer. In this case that's integer, integer, and integer. It does not depend on the parameters provided. Just we do not really know which actual parameters. From here we don't actually know which parameters are provided. Is it AB or AC or BC? We only can see that we provide integer and integer. So the problem is that we can actually determine if which of A, B, C parameters are provided. We only know that int or int signatures are provided. So this is what it is about. Yeah, we can implement it in kind of way of optional parameters, default parameters, but this can be done so precisely as it is done in other language. Because let's say, for example, in PHP, how is it done is that but yeah, in PHP that's there's also a similar way. Yeah, that's and the signature is defined by the parameters here. So that's the issue. That's the problem which present for the method overloading. Also, yeah, the last thing, let's see what we have next? Yeah, maybe last thing what we talk today is the overloading of the constructors. So as you remember, we can have different constructors in our classes. Yeah, and then it depends on what we pass to the constructors. We may have different constructors, different implementation for different type of constructor. So the same as for the methods. Okay? Same as for the methods. Constructor signature should be unique for each one. Alright, and yeah, here is the example for the constructor overloading. We have employee, and this is what I said. We can have the base salary, the base value, the default value. And like in this case, if we do not provide, if we don't provide the salary to the constructor, then the base salary is used. Okay. In this case, and basically how do we do? This is basically the same as when we use the overloading, so overriding. So there is something similar when we talk about overloading and when we talk about overriding, because the similarity is that again, as I said, the overriding can be used to extend the functionality of the existing method from the superclasses. Then the overloading can be used in the same way. So it means that we call the, right, what you see in this case, when we call the constructor which has one parameter, then from here we can use some default values, and then we call the constructor of the with the two parameters. In this case, that will be name and base salary. So we call another constructor from here. And so this would be this constructor, and this constructor also calls another constructor and adds default value here as well. And from here, here we have three. Here name salary, and so that's. So what have I missed? So that will be name, that's string, salary, and oh yeah, okay, so this one. Yeah, then this one will call them. This one then will call the method. This constructor, name, salary, and date of birth. In case you call the constructor without that would be without the date of birth. Sorry, not without, but without the salary, but with the date of birth. Then you call this constructor. Then the base salary will be used as the default value for them. So the default value will be used for your salary here. And then again, at the end, you also call the constructor with all the parameters. So basically, in this case, as I said, the overriding can be used in a similar way as the overloading is used. Because again, as you remember, overriding means that we extend the functionality. We can call the method from the superclass and add some more things from our side. So the same as here, but yeah, here that may work in opposite way. Like you start with more general, then you add some default values and go to more specific way. So we extend the functionality, but in case something's not provided, we use the default values. Okay. Yeah, the last thing for today is the constructors are not inherited. Child class inherits all methods and properties from parent class, but child class do not inherit constructors. That's partially true because actually when you call the when you create the instance of the subclass, then again, as I said, the instance of the superclass is created. And in the same way, this means that the constructors of the superclasses will always be called when you create the method, when you create the objects of the subclasses. Okay, so it means that you have top-down design. And the last thing to show today is that you have top-down design, let's say, and you have the class somewhere at the bottom. Then it means that when you create the instance of this class, then please remember that the instances of all the superclasses will be created as well, and it means that all the constructors of all the superclasses will be called. Okay. That's what it's about. This is basically how that usually happens. Okay, I think that's it for today. So in case you have any questions, please ask. As usually, I will stage the changes and push them into the remote repository. Right, so that's done. Okay, thank you very much for your attention today, and then meet you all on Friday. Bye.